everybody, and welcome to another episode of Adventures in Machine Learning. This week on our panel, we have Gant Laborde.
Hello.
I'm Charles Max Wood from devchat.tv. This week, we're talking to Beril.
Very difficult to pronounce. Okay, it's Sirmacek. I take it over.
Thank you. I'm terrible with names, too. I mean, I screw up regular English names, so... Anyway, do you want to introduce yourself real quick?
Yes, thank you. I'm Beril, so don't mind the surname. I'm a Dutch scientist. I'm an AI computer vision scientist. I'm very much interested to make machines or any other small devices see the environment with intelligent algorithms if possible.
Are you a software engineer trying to learn machine learning? Then you should check out the course from educative.io called Machine Learning for Software Engineers. It has 87 lessons, 8 quizzes, 115 challenges, 163 playgrounds, and 2 code snippets. In other words, it's not just a set of videos that tell you how to do the thing. It actually walks you through all of the processes for machine learning. It gives you quizzes, it makes you do challenges, it's very hands-on. It's done with experts from companies like Google, Microsoft, Amazon, and Apple. And it is a terrific course that I've been learning to do machine learning. So go check it out at devchat.tv/learnml. That's devchat.tv/learnml. And that'll take you to the right place so you can sign up for the course.
So currently, I'm actually working as an assistant professor at Jonkoping University in Sweden, but I'm staying in the Netherlands at home due to COVID situation right now.
Oh, wow.
And I'm doing research in a nice AI group called JAIL. It's Jonkoping AI Lab, short. So I'm doing AI projects and teaching AI-related courses at master level there, and also doing my own projects during summer. At the moment, I've got a little bit more time to get crazy and try more AI algorithms. So I'm very happy to be here and looking forward to our chat.
Yeah, absolutely.
Wow. There's so many cool things that you're working on. That's awesome.
Thank
I know.
you.
I was trying to think what it'd be like to be that insanely busy, and then I realized that I'm just doing other stuff. So
awesome.
I'm not sure where to start. I mean, AI professor, that sounds really cool, but also the computer vision. Why don't we start there with computer vision? I'm a little curious. I mean, we've talked a little bit about some of the things that people can do with computer vision, but how is computer vision different from other forms of machine learning or other applications? Or is it more or less the same thing applied to a different problem?
Yeah, thanks a lot for asking this thing. Well, I don't want to make anybody feel offended by my answer to this because, that's a little bit sensitive area, but very important question that you're asking. Computer vision has been different than AI and machine learning. We try to develop algorithms which can determine significant things in the images, then make the algorithms recognize, for instance, what kind of object it could be. In the past, we did a lot of feature engineering and developed algorithms like filters, for instance, which give response. The filter, for instance, a specific convolution filter designed for a specific object detection algorithm to give response when similar object parts are seen in the image. Then we did, for instance, probabilistic algorithms and graph theory, for instance, to understand if this response altogether generates the object that I'm looking for. So we did a lot of hand-tailored algorithms to recognize specific objects in the past. And neural networks, of course, is not something new since 1970s or even earlier. Neural networks were there. And in my education, for instance, I had a neural network course. We had 2-layer network, which we embedded in FPGA that time. And we didn't have GPU like something. There was no TensorFlow like things, of course. And we didn't do any image processing because it wasn't possible to process any image with neural network. It was too heavy to do. And now we are in a time that Gant has showed something just by hand. Very tiny thing that you can process lots of stuff, or even with your smartphone now you can run TensorFlow and you can do a lot of real-time image and video recognition algorithms. How they are working, you're given a lot of images, examples of this is how apple looks like, this is how dog looks like, this is how flower looks like, thousands of images, and you train a model which can recognize it now. And those are also called computer vision at the moment. So were we doing computer vision? Yes. And are they doing even better computer vision right now? Yes. And I'm a little bit, I'm feeling bad about the computer vision right now, even though it works better. It's like we don't know what we are doing. I mean, model is learning something, and anybody who can program and use computer and TensorFlow and write some Python code is doing computer vision at the moment. I really don't want to offend those people, but I really want to get some attention to focus on, are we really knowing what we are doing? So I'm from computer vision area. I'm feeling a little bit bad that we are using those algorithms and getting very nice results at the moment, but we don't know what we are doing. In the past, we were doing computer vision, little bit less performance maybe, but we knew exactly what we were doing. I mean, we used to explain it mathematically. So,
well, that's a bit of a portent for all of us, because I feel like what we're seeing there, people who used to do it one way and then machine learning came along. We might have that for every aspect. It's like, I used to build web pages by hand. And then it's just like, and now it's going to be, I would like my website to look a little this way and that way. And I mean, I don't think we're very far from, especially with all the generative models and algorithms, we might be applying, computer vision might be dominated now by neural networks and deep learning. But I feel like it's just going to continue on into all the other fields of programming.
Yeah. So my first experience with computer vision was my capstone project in college. I was a computer engineering major, and we had to build a robot that would follow a course with white lines down the side, right? So we had a really complicated system set up where essentially it would take a picture with the camera, and then it would just look at the pixels, and where the pixels were white, right? It would try and steer toward the middle of that. I mean, it was, looking at computer vision now and the AI algorithms, I mean, you could literally just build a couple of mazes, you just run it through a bunch of mazes until it starts getting them right. And you have that neural network, you have the feedback, you have the algorithm. But yeah, it's also interesting that at the end of the day, you don't actually know what any of those weights mean within your neural network to know exactly why it made the decision it made. You just know that somehow it figured out that if there's a line to the right, you want to.
But not to say one is better than another or they are doing wrong way. Both of them are right, but we have to now understand each other, the old methods, traditional methods, and the new ones, and we have to find new ways to combine this information to understand what AI is doing and how to improve it with the traditional methods. And this is why we've been talking about hybrid systems more and more these days. There is no way to go towards AGI right now. It's not like giving tons of data and expecting a good model to work everywhere. Computer vision, like all traditional methods, must explain things to us and create maybe better models, or to select the right model which works in different conditions, and knowing the condition, which state I am and which algorithm, which model should I choose right now to get my results. Just an example, for instance, my student was working on computer vision part of a self-driving car, and he's got a lot of data of streets, and those street data is collected, it's an open data set, a big data set collected in Germany, and they drove hours and hours in Germany and collected a lot of data to do semantic segmentation, and you directly classify the road and cyclists, pedestrian, buildings, all of them are colored. You've seen those images, and he's got those images and trained a model. Then we together drove with a webcam on our dashboard, and we together drove in the car here in the Netherlands. and the classification performance was terrible. But it works very good in the data set. Why it's not working in real when we drive here in the Netherlands? Then we were looking at our images. In the Netherlands, there are more brick buildings. The buildings are all red in our street. And none of those buildings are detected, segmented. Because in the training data set, when they were driving in Germany, there is no brick building. And they've got more white-like buildings or yellowish buildings, which are like beton, we say. Even there are in neighbor countries, the training data set looks very different. And then assume that you made a self-driving car and trusting on this computer vision algorithm, you start driving somewhere in Germany and you want to drive to Amsterdam. It's not unrealistic that happens. And then do you expect that you drive very nice in Germany and suddenly you enter to Netherlands and everything messes up? That shouldn't be what we expect from AI that we can trust, right? But what happens if we really try to understand how our algorithm is responding, how our environment is changing, for instance? And we can use computer vision algorithms to understand our state, where I am and how it looks like, how the scene, how the area looks like. Then maybe I can either generate a model based on computer vision algorithms, so combining and training in a different way, or create different models for different scenes. And computer vision algorithm understands the scene and selects the good model, or create something in a different way. But we need to find a way to merge those traditional methods with the new ones. Maybe do something probabilistic. It looks more Netherlands-like than go to this model like something. I don't know, but there's no another way to go to AGI if we are not merging those old and new techniques.
That reminds me of a story. Has everybody heard of the story of using neural networks in the 80s with tanks, the US? No. There's this story, and it seems to be somewhat unfounded, but it's hilarious that they the military was trying to train cameras to identify the difference between an enemy tank and just regular forest. So they found they were able to get this level of accuracy. And what they found out was they took all the photos of the tanks one day, and then they took photos of the trees another day. And so they trained the algorithm. And what the algorithm actually learned was if it's cloudy outside, it's a tank. It should be the worst.
Well, it's funny, and it's kind of the point that I was making too, right? We have a normalcy bias, and what that really does is it allows us to filter out all the things that we're not really paying attention to, like the color of the building or the material that it's made out of, or are they using slightly different paint on the roads in one country versus another, things like that, right? Same thing with the tanks versus the forest, right? Is they were focused on the tank and the forest and didn't account for the other things that they had just filtered out because it's normal for it to be cloudy on a given day. Yeah. And so, sometimes you're looking at things and you're thinking, okay, well, is it my model? And in reality, it's your data. And sometimes you're looking at it and you're thinking, well, do I need a different data set? And maybe a different model would give you a better result. So how do you balance that? How do you know that?
In computer vision field, we are a little bit lucky because everything is visual. Everything is about images. Right. That's why, for instance, there are now popular algorithms like LIME, for instance. It's trying to show us where the algorithm is focusing in the image when it's making the decision. For instance, again, made an example of clouds. If we give the algorithm to LIME, it's written LIME, it will be showing us where it's focusing on the images when it's making decisions, and we will see the results clouds are highlighted, for instance, in the decision-making process. So we will exactly realize where the error is coming from. Then maybe we have to work on our training data set, but we cannot work on the model itself. We again need to rely on how the model is learning by itself. But I'm not pretty sure myself, but maybe we have to manipulate the learning process of the model. Maybe when it's trying to find the local minimum, maybe we have to manipulate those neural network layers. We have to manipulate maybe activation functions, or during the learning process, maybe some computer vision algorithms need to manipulate what things are activated and what things are not.
Cool. So you're working on a driving car project, and it seems like you're always working on really cool stuff. And I met you back when you were a dean of School of AI stuff. Can you walk us a little bit through, so we can hear a little bit more about you, because we've already got all these exciting opinions. What are some other things that you're working on? How did you get started? I mean, I guess the adventure of your particular machine learning journey.
Yeah. Well, I've been working on computer vision since maybe 2004, 5. I mean, it's more than 15, 16 years of my life, I've been working on computer vision area in the academic field. And
Nice.
mostly tailoring features to detect a specific object and to track them or to make 3D reconstruction. And during the process, most of the time, machine learning algorithms are needed, for instance, to go to a latent space or to reduce the dimension of the feature descriptor with PCA, and then do a classification of them to select the features which are not noise, for instance. So machine learning algorithms are always coming, but training a neural network was not possible indeed. I mean, that wasn't there. There was no possibility to do such a thing on small CPUs we had that time.
Yeah.
Okay, they made, for instance, when I was early at my university, they made Cafe, for instance. They made the libraries available. And Cafe was trying to help with building a neural network. It was an early algorithm for like TensorFlow. And then still TensorFlow was not there. And there wasn't a community, YouTube videos, and like everything is shared on Twitter. It wasn't so much available to develop. How can I train a model which learns from images? And in AI field, in learning with creating models which learns from images, honestly, I'm also very new. It's the last few years we are working on how the neural networks are able to learn from lots of images. So I'm trying to combine my past with this new area myself, also with programming. But you mentioned School of AI and the other stuff. These are all other social activities that we try to do with coming together and learning from each other. And School of AI was an initiative. Well, it started with Siraj Raval that time, and he said, I select some people from each country and you start your own thing. So that started with like that, and it was a good idea. I really liked the idea. And at the beginning, I couldn't gather people easily in my place. It wasn't so easy to make people eager to let's come together and discuss AI. And I didn't know where to make it. For instance, I had to communicate with lots of people. Can I use this room and stuff? But in the meantime, I really wanted to get started. I mean, the easiest way to start right now is to use internet and technology. And with COVID periods, now everybody learned that, but I learned that time that we can use internet technology to get together. And well, we started also online by doing YouTube videos and introducing what we are interested in the field of AI. And those YouTube videos are still around. I didn't delete anything. If people didn't ask me to remove. Some people asked me to remove, I removed them. But
oh, wow.
The others are always there. I'm open to share knowledge, experience.
Yeah.
And then we started to get together in real at the university environment. And I was so happy people came to meet us every month. An increasing number of people came to every event. And we had invited speakers, and we had you also again
Yeah.
with Nicolas Cage.
I'm never going to live it down. I'm just owning it now.
You got the important people. You got Nick Cage and Gant the board.
That's it. What more can we do? So, did you say people asked you to remove some of the interviews that you had with them?
Yes, there have been few requests. I mean,
wow.
I interviewed a lot of people, maybe more than 100 people in my YouTube.
Yeah.
But maybe 2-3 of them asked me to remove it later. That's
I'm trying to take over the world.
I'm
Don't tell
fine.
anybody.
Yeah, is that what happened? Like, I wonder. Like, I've never been asked to remove a conversation, so I have actually. All right, okay, you get, yeah.
Yeah,
So,
I think after some bad things are written about Siraj Raval, even though it was, my YouTube conversation was not really referring to him, but still the name of School of AI was found related to him.
Yeah, actually, I don't know if you know about that, Chuck, but Siraj, I think is sort of like still a no person in this field. But he brought so many people together. I think that's really the best part, is the superpower of all these people looking to learn about AI kind of flocked and met one another. And that was the best part about it. And so I don't know why people would want to like delete that part of it. But
maybe they didn't want to be found on internet related to something which reminds of Siraj Raval. I don't know.
That's possible.
I could also delete everything if I wasn't minding. But I don't mind, because I did it for myself and for other people and for everyone. I mean, still, I think it's valuable. There people share their own experiences. People shared some links and showed some things that they do. Those are all valuable things. I think 10 years from now, when I look back, I will find it even more valuable that we did that.
Yeah, absolutely.
It's so nice that we meet each other. I mean, maybe we will never meet real, but it's so nice opportunity that we made it online. I really honored it.
Leveling up is important. I spend at least an hour every day learning ways I can improve my business or take a break and listen to a good book. If you're looking to level up, I recommend you start out with the 12-week year as a system to plan out where you want to end up and how to get the results you want. You can get it free by going to audibletrial.com/code. That's audibletrial.com/code.
Yeah, the COVID is kind of the big limiter of anybody meeting anyone real, right?
Yeah.
I think I want to go talk to someone I have a friend of mine who lives less than a mile away. I think I have never seen him during this entire time. So
yeah. But I'm scared of flying. I mean,
I
know. To the United States, it's a little bit too much. I need a ship like Greta.
Well, that's actually really fun, kind of like just in the vein of AI, not specifically, but there's been so many cool, I can't even keep up with all the machine learning applications to COVID people have come up with. I tried keeping up with that, and there's just researchers on contacts, researchers on early diagnosis, research on this and that.
All of
it's
them
really
are sharing for free. They all open.
Yeah. Nice people.
I found it so amazing. Suddenly, all researchers from chemistry, biology, from medical, AI fields started to share all their data, source code, all free, and started to work together in Slack channels or another way. It's so amazing. If we want, we can really do a lot. We solved it.
Yeah, I've never seen a community come together like this. It was awesome.
Yeah, and I was just impressed. I mean, the algorithms sometimes are a little bit proprietary, and so people don't want to share those. But usually it's the data that people just, they'll fiercely defend.
Yeah.
And, if I find some novel way of looking at the data, or I find an algorithm that gives me a novel way of looking at the data, I love that, okay, I ran this across California's data, and now I'm going to run it across Italy's data, or vice versa, right? And see if the trends hold, and see if the prediction models work, and see if, anyway, it's really, really fascinating just to see what we're able to do if we all come together.
Exactly.
I think it was
we really carry this feeling with us even after COVID.
Mm-hmm. I think it's like, I might be wrong, but I think it wasn't penicillin, whatever the diabetic medication is that people need to take. The patent for that was sold for $1, because scientists knew that, well, penicillin was released early, just say like, here, everybody, you need this. And it's just like when science comes together, it's very selfless, and I think that's really cool.
Yep. Yeah. So I want to ask about professoring.
Ooh.
I know that's not a word. Sorry. How do you become a professor? Do you just get a PhD and then apply to a college, or is it more involved than that?
Yeah, I've been involved in academia for a really long time. I mean, my PhD was more than 11 years ago from now. So getting my PhD. So it was in 2009. And since then, I've been in academia and I've been already teaching in many universities, many different universities. And of course, involved in many scientific activities like organizing conferences, workshops, and also publishing a lot in the area. And therefore, it's not a big surprise to end up in a faculty position. But still, it's very lucky to end up in a faculty position because it's also a very competitive area. And there are not so many faculty positions opening. So that's especially in the field of AI. I found it very competitive. So I'm feeling really blessed to find the position which offers me opportunity to teach in the field which I enjoy to teach and to make conversations. I mean, then the life goes like fun, even though it's very busy sometimes. But
makes sense. Where do you find that people, teaching AI, and Gant can answer this too because he's put together a course on AI, but where do you find that people struggle? Like when people are starting to get into AI and they're trying to figure out what's going on there. Yeah, where do people get hung up?
I think in the field of AI, when we are teaching, as teacher, the most difficult thing is the time we spend to create course material, because it's not like teaching fundamental things like mathematics or other. I mean, you can get any book, any reference book and make a course layout and teach everything, design your slides by looking at a book, getting it as a reference, for instance. But in the field of AI, everything is very new, especially if you are making focused courses. For my courses, I couldn't find one reference book, for instance. Therefore, I started to write my own book right now. It was too difficult for me to have to make a layout of this course because it never happened before. It's very new to teach these kind of things. So we say the neural networks were there. I mean, it's easy to teach neural networks, but to make a specified course, a master course in the field of AI is something very new. And we have to come up with what teaching goals we should put and how to make a course layout which really addresses these things, these teaching course, how to make exercises, which also makes a good level. I mean, some things are so easily found on internet, like classification of cats and dogs, for instance, but they have to, we have to find a way which is not too challenging that they give up, but not too easy that they just run an existing Jupyter notebook and they don't really get involved within the code. So finding a good balance, finding a good layout, those things, just because it's very new, it's been really very much time consuming to build a course.
Yeah. And one thing I'll kind of throw into that, you've hit it right. It's that balance of reward versus work. And, I always think of when I first started trying to learn electronics, when I was like, oh, as a kid, I'm gonna learn about this and that. And the sort of like the amount of math to do basic electronics was extremely high. And then what you got is, you lit an LED without it popping because you did the right stuff. And you're like, okay, well, as a child, you're like, all right, I have to understand algebra and I have to understand resistor codes and I have to understand, and I can't mess up these parts. And, sometimes it's like something's broken, your capacitor's broken, the LED was already popped, and you have to have this level of organization. And I look at children learning about electronics today, they're like, you put the LED box next to the battery box and it lights up. Like, it's been simplified so much. And I'm just so upset. They're like, I'm going to build a radio. And then they just got to like Lego 3 things together. And they're like, radios, they're easy. I don't know what a radio is. Yeah.
Have you seen the book Neural Network for Babies?
Yes. That will put any baby asleep. Yeah. It's time for you to sleep. Let's start talking about linear algebra. And, whatever. Let's do back propagation tonight.
Yeah. Oh, I remember my linear algebra course in college. Both times I took it.
Easiest class both times.
Oh, I passed it the second time. Same with ordinary differential equations.
Yeah.
Gant must try this and give feedback next time.
Yeah.
There we go. But I hear you, Gant, on that. And it's not just even the pieces; they only go together one way, right? So you can't put them on backward,
you can't even mess them up. But that's where we're at with, I think, like AI, right? I think that I really want to kind of understand some of these things. All right, well, you need to use this mathematical terminology. You have to learn these kinds of words. And if you put this together any bit wrong, hours later, you will find out.
Yeah.
And so I think that's a barrier for a lot of people because no one wants to solder for 5 hours just to find out the tree doesn't light up or something.
And students are really very much interested to do something which works. They are so enthusiastic to make something which works. They don't want to spend a lot of time in the mathematics, but at the university, you also cannot give only things which work. You also need to mention how it works. I need to deep dive into code and algorithms, mathematics, sometimes no code at all, just the mathematics sometimes. But it's difficult to get the attention, but then also related to something which works. Yeah,
absolutely. If I have to see, let's estimate housing prices one more time. Like, I'm not a real estate agent. That example does not carry for me for linear regression. I'm like, okay, housing
but it always ends up with a good discussion. I like the house prices and this stock prices example. It always opens up nice discussion in the class. So why am I not very rich right now? Tell me.
Yeah, right. Yeah. But that's the other thing, right? Like if you're like, hey, if you've got someone who's not driving around a Mercedes, well, the Mercedes doesn't mean anything over where you are. You're not driving around you're not driving your Tesla around. And it's like, all right, let's talk about estimating stocks. You're like, well, just consider the source here for a second.
Yeah. So I'm curious because it seems like a lot of the new ideas come out of places like universities. Or sometimes they come out of companies that are, trying to find some novel way of doing something, something that's more efficient or more whatever. Where do you see the future of computer vision going?
Well, the future of computer vision is definitely finding new hybrid ways first. As we talked, I don't know exactly how it's going to happen, but we are trying different ways of combining things. These traditional methods need to be introduced again, and there are lots of mathematics lost within the time. We have to bring them back to understand what we are doing with AI right now better. Hopefully, it will end up in a place which recognizes in more changing environments. I mean, more robust computer vision, not computer vision which understands everything, but a little bit more robust to at least changing environment. Like if you are driving from Germany to the Netherlands, it shouldn't get lost. It still needs to recognize things. Or what I heard once, a friend of mine actually defended his PhD thesis on skin color of people, which is hot topic at the moment, but that was 10 years ago, like something like that. He proposed something like that in his PhD thesis. Skin color of a difference between different people is less than skin color difference of the same person under different lighting conditions.
Oh, wow.
Is it right English? I don't know. For instance, you change the light. So, for instance, you change the light and you make pictures of my face. My skin color change on the images, what computer sees, is larger than what it can see when different people come next to me and the skin color between us.
Wow. That's really impressive. You know what? That's one of the things where no one believes it until you have another one of what's the color of this dress things. Do you remember? Is it white and gold or blue and black or whatever it was?
Yeah, big discussion.
Yeah, no, and everybody's like, oh, well, it's so silly, it's this, it's so silly, it's that. But what the trick behind that was people were thinking in two different lightings. And if you think of it as in the shade, it's one color. If you think of it in direct sunlight, it's another color. And as human beings, we do a shading bias immediately so much that it's really difficult for us to even perceive that it's not that, or that we don't even think about it. It's not a cognitive part.
Changing light, you will recognize me anyway.
Yeah, exactly.
Right.
But the computer doesn't do that.
Yeah.
And still, we don't have algorithms who can do that. Okay, the iPhone, for instance, turns on unlocks when it sees my face, but they are also relying on other things like 3D depth and stuff. You cannot do with computer vision alone. It's too difficult.
That's interesting.
Wow.
I didn't even realize that.
Mm-hmm.
I'll tell you, I'm a different person at night. Anyway.
You just left that open and all we're like, let it
I'm a
go,
werewolf.
buddy.
Anyway, so but yeah, no, it's really fascinating. And again, it's back to that thing where our brains just filter, those things, and we don't think about the fact that the computer doesn't have a way to do that, right? That's what the machine learning is actually there for in some cases.
Yeah.
Yep.
And where the computer vision is going, hopefully it can become a little bit more robust to understand such changes. For instance, Gantt made it a little bit more clear, understanding the environmental shading, or if it's a bright environment. For instance, such things are too difficult still in this age.
Yeah. Wow.
Yeah.
Cool. Well, I'm kind of under a time crunch, so I'm going to start heading us toward wrapping up. But if people want to see what you're working on now, Beril, what do they do?
It's nice that they visit my website and also follow on Twitter, and maybe they can go to newsletter in my website. And every month I'm sharing free newsletter with updates from me, and also I'm sharing lots of free source code and data sets which I gathered around and didn't have time to work myself. I couldn't make it. Please, you do it for me. I'm sharing lots of stuff, so it's a way to follow.
We do have an outsourcing show on devchat.tv. I admire that. Anyway, that's great. What's your website?
I will give you after this talk if you want to put somewhere, but it's my first name and last name.com. It's all together. Yeah.
Yeah, just put it in the chat and we'll make sure it winds up in the show notes. All right, well, let's go ahead and do some picks. Gantt, do you want to start us off with picks?
Yeah, awesome. So the picks portion is where we choose something, and it could be about anything that we want to highlight for a moment here. And I'm going to highlight specifically that today on Twitter, so in the past, by the time anybody listens to this, I've got quite a few conferences coming up. I'll be talking about AI at some of them. I'll be talking about mobile at some of them. It's going to be a lot of fun. So I'll be talking at the React Native Remote Conference. I'll be also talking at React Native EU online. So that's 2 mobile conferences coming up, and I think it'll be really fun. I promise if you want me to build some cool AI stuff with mobile, chat with me, and that might be a fun thing to add here and there. So definitely check that out. I have them on my website at gantlabord.com. But yeah, I'm really excited. 2 React Native conferences coming up this year, and this should be really fun. So definitely check out both of those.
Awesome. I'm going to throw in a few picks myself. The first one is just finished a book called Warbreaker. It's by Brandon Sanderson, and it's one of his first 3 or 4 books. But anyway, really enjoyed that. It's extremely well written, but that's Brandon Sanderson for you. In fact, funny story, but a good friend of mine from high school actually works for Brandon. So they bought the house next door to where Brandon lives, and they basically converted it into the headquarters for his stuff. And they call it Cosmere House. And my friend asked me if I wanted to come see it. And I was like, yeah. And so I got to walk through and see all the things that they have there. And it was funny because he's like, now you can't tell anybody about these things that we have here. But if you've watched any of the live streams where Brandon's signing books or anything like that, I saw where all of that happens. They basically converted the entire basement into just rows and rows and rows of, you can get I got some Doomslug socks if you've read Skyward, which is another one of his books, one of the newer ones. I wound up walking out of there with a handful of paperbacks and leather-bound copies of all of the Mistborn books signed. And yeah, anyway, it was really, really cool. So I'm an even bigger fan now. We'll just say that. And I know where Brandon Sanderson lives is about 10 minutes from here.
Wow.
So
awesome.
Anyway, so that's my pick. Just kind of a fun experience there.
I have to say, just as a tidbit, I've always dreamt of the idea of buying the house next to my house or buying the house next to something and then just turning it into a work area or something. Just that the fact that someone did it now just makes me that much more jealous.
Yeah. Yeah, I had heard rumors about how it went down, and I was wrong. It turns out that what they did is they actually offered to. The neighbor wasn't selling; they hadn't listed the house. They just offered to buy the house and then paid the movers to come move them out.
Wow. Wow.
So
all right. So my dream's still alive no matter where I live. Yeah, I don't have to wait for the house next to me to go on sale. I just have to go over there and make an offer they can't refuse.
Yeah, exactly. All right, Beril, what are your picks?
Oh, I think I mentioned a lot, but this summer I'm also a little bit writing my own book.
Yeah.
I can announce that someday, but yeah, people can hear if they follow on Twitter or newsletter. Yes. But I don't know when exactly finish. I was assuming that I can finish in summer, but it's just going more and more. I don't know when. But as I said, it was too difficult for me to find a reference book for my own course. And then I started I just put my own stuff here.
Nice. Well, I want to buy a signed copy, especially if you buy the house next to you and finish writing there.
I will send you, of course.
Awesome. All right. Good,
Promise, recorded.
Yes.
There we go. It'll be a collector's edition.
Yes, indeed.
Oh.
All right. Good deal. Well, thank you for coming, Beril. This was fun.
Thank you so much for the invitation. Great to talk to you.
All right, folks. We're going to wrap this one up. Until next time, max out. Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CacheFly.com to learn more.